Welcome to today's session, Architecting Oracle Workloads on Oracle Cloud VMware Solution, OCVS. My name is Sudhir Balasubramanian. I am a staff solution architect and the Oracle practice lead for VMware.
My name is Faisal Hassan. I'm a senior principal product manager at Oracle for Oracle Cloud Infrastructure.
Good. Standard disclaimer, so we can probably move ahead with this. All right. So let's have a look at the agenda for today's discussion. Essentially, we'll start with talking about the benefits of running Oracle workloads on a VMware platform. We'll follow that up by what customers really want, which is VMware Hybrid Cloud. We will then introduce Oracle Cloud VMware Solution, and my friend Faisal will then delve deep into the Oracle Cloud VMware Solution and what that solution proposition is. We will wrap up with a lot of collaterals, and hopefully we'll do have some time for some question and answers. But let's get started. All right, so let's take a look at some of the benefits of running Oracle workloads on a VMware vSphere platform. But even before we look at the advantages of virtualization, let's understand what Oracle business critical applications are, what are the requirements, and then understand the benefits of running these business critical Oracle workloads on a VMware vSphere platform. See, any application that is deemed business critical will have certain SLAs. They'll have certain RTOs, they'll have certain RPOs. Essentially, they'll have a set of stringent requirements. For example, availability. Well, this application must be highly available. This must be resilient. This must be redundant. The mean time between failures, that must be very high. Performance, right? All the process completion, it has to complete in a timely fashion and must avoid all the bottlenecks. Of course, it should be recoverable, which means the RTO, the RPO, the MTD, the WRT, they must all be very low. All of the recovery plans must be verifiable and repeatable. You should be able to scale up, you should be able to scale out, you should be able to add compute, memory, storage, CPU, memory, everything on the fly. So there are many benefits, not particular to any VCA vertical, which basically helps all workloads when we run this workload on a VMware vSphere platform. So for example, resource maximization. See, with the server resources increasing too much for one application instance, what happens is virtualization basically improves the resource utilization, and essentially it results in reducing wastage by fully utilizing the hardware. You're also able to maintain the application isolation, right? What we also get is enhanced availability. And I'll give you an example here. If one were to run Oracle RAC on a VMware vSphere platform, what one gets is an application level HA on an infrastructure level HA, which is provided by VMware vSphere platform. And if we were to stretch that infrastructure across metro distance, what one gets is site level high availability. So simply by putting your Oracle RAC on a VMware vSphere platform and stretching that across metro distance, which then results in an extended Oracle RAC configuration, you are able to achieve 3 levels of high availability: application, infrastructure, and site. And there's just an example here. So the third thing that comes to my mind is performance, right? So I/O is not an issue. You're able to scale up, you're able to scale out. Essentially, all of the newer hardware can increase performance, right? And then to add, features that vSphere provides right out of the gate. Example, DRS, your distributed resource scheduler, the vMotion, the storage vMotion, so on and so forth. If we look at this slide here, right, essentially, if you take a look at the slide here, all the processes, right, nowadays all the processes are getting faster, caches are getting bigger, the NUMA awareness is better, all the hypervisors are getting smarter, and storage is faster as well. So this makes it perfect sense for virtualizing most of the applications, right? So with every version, VMware has been increasing the performance and scalability by leaps and bounds. So any lingering performance concerns, related to VMware virtual machines, they are clearly due to a lagging perception from very early generation, which essentially, I do agree, had limited capabilities, right? If one were to take a look at the config maximums for the virtualized compute, and the link is there in the bottom of the slide, we can see with the current version of vSphere, you're able to sustain the virtual machine workload for as large as 256 vCPUs, right? Memory can go as large as 6 terabytes of VRAM. You have the option of adding NVMe controllers. You have the options of adding NVDIMM controllers, right? The number of VMDKs per PBSCSI controller has actually increased from 15 to 64, and that across 4 PBSCSI controllers gives you a total of 256 VMDKs, right? And that's in total of a VM. And then that multiplied by a max of 62 terabytes for a VMDK, well, that's, a lot of storage then one can address essentially, right, virtualizing your Oracle databases and putting that in a virtual machine. You guys can do the math, right? So the question still, this question still begs here as to what is so unique about virtualizing Oracle database workloads. So here's the thing, right? Unlike virtualizing Exchange or SharePoint or web server, database workloads are very unique. The database workloads are extremely CPU, memory, and I/O intensive. They have different capacity requirements than most applications. Let's take an example here, Oracle RAC. Now, RAC imposes unique network, storage, and vCPU configurations. So what one needs to keep in mind is the virtualization best practices that must be strictly adhered to, right? Or the performance and availability will suffer. And the other thing that I'd like to mention here is typical consolidation density thought process that must be readdressed when one starts talking about running business critical applications on a VMware vSphere platform. Right. So let's take a look at the Oracle workload design methodology. I mean, this is an overview of the Oracle design methodology here, right? But essentially, one starts with the process of requirement gathering, and at some point of time, we have to sell the project to the stakeholders because we want buy-in from the stakeholders. And then, before we start the project, we have to understand what are the current environment constraints. And once we do that, we then have to measure the current database workload. And once we do that, that helps us in coming up with a good design for the cluster. And then the step after that is essentially how do we migrate the database from a physical architecture to a VMware vSphere platform. And then following that, you have to talk about support and licensing. You have to find that in the conversation as well. We also have to inculcate best practices when it comes to design considerations for sizing. We then need to inculcate the backup, the recovery, the high availability, the disaster recovery. And last but not the least, one needs to make sure that you're able to set up good monitoring and tuning controls, right, or mechanisms in place. So if you look at all these steps of the design workflow, there is no one step that is particular to any architecture, whether it's physical or virtual. So all we're trying to say here is there is no change in the design methodology when one virtualizes Oracle on a bare metal architecture versus virtualizing Oracle on VMware vSphere platform. All right. So this is essentially the recommended approach to sizing Oracle databases workload for replatforming, right? So let's say we have decided to virtualize our Oracle database workloads, right? And at some point of time, the virtualization timeline, that's a very important factor here, right? And then we decide, once we ask the business, and the business they come back to us and say, yes, we need to virtualize ASAP, which is the fourth in the left here, right? Then one has no choice but to essentially pick up and drop approach, right? Which means the physical environment is going to match the virtual environment as is, right? So there is no savings in resources. And at some point of time, you'll have a lot of wastage in servers as well. And in terms, it's essentially garbage in, garbage out, right? But if you look at the process in the right, wherein we do have time, right, wherein we can do due diligence, we can do a plan and design exercise, we don't have to move ASAP, then what we recommend is based on the business peak period, right, measure the database workload using AWR and then operating system statistics like either SAR on Linux or Postman on Windows, and based on that, we can come up with a very good design for the cluster and also for the database. So once we do due diligence, we know that there will be no wastage of resources once the virtualizing the exercise is completed. All right. And I mentioned that before in the previous slide that performance best practices, I mean, this is very important to make sure that best practices are inculcated in every layer of the stack, not just at the database layer. It has to be done at the operating system, the virtual machine, the VMware infrastructure layer as well, the storage and so on and so forth. Right? But if we take a quick look at some of these best practices, essentially, what we recommend here is use para-virtualized SCSI adapters. Essentially, those are adapters or SCSI adapters on Rocket Fuel, right? And that would increase the performance of the database, right? So use all 4 PV SCSI adapters whenever it's possible, right? Essentially, the other recommendation that we have is use huge pages. Use traditional huge pages in the guest operating system because Esxi has its own flavor of huge pages, which is 2 megabytes, and it will protect the guest operating system, right? Regardless of whether you use huge pages or not. So it's a win-win situation if one were to use huge pages in the guest operating system along with using huge pages on the Esxi platform. right? The other thing that comes in my mind is use DMX Net3 adapters where possible. The use case here, for example, Oracle Rack Private Interconnect, right? That's what we recommend as part of our best practices. NUMA, the designing with NUMA is very important. And if you look at the last bullet point here, which is very critical, essentially, make sure that you test your workloads when you are inculcating all of these recommendations. And the link at the bottom of the slide, that essentially is a link to the Oracle databases on VMware, best practices guide. So please do have a look at that. But moving on. Okay. So with 6.5, with VMware vSphere 6.5 and 6.7, right? A lot of features were announced, which were very beneficial for BCA, business critical application workloads. Some of them notably being the NUMA, right? The cores per socket dependency, well, that was disconnected, right? The fact that you have virtual hardware 13, which means you can now have virtual machines which take 6 terabyte of memory, which is maximum, right? The fact that now you have virtual NVMe adapters, the fact that you can now have NVDIMMs, persistent memory, right? You can have that, allocated to the virtual machine. The fact that you can use para-virtualized RDMA, PV-RDMA, and the use case here is Oracle Rack Private Interconnect. The fact that you have 512E drive support, right? I mean, the list goes on, but this is just in a nutshell. We wanted to show you what are some of the notable features with VCF 6.5, 6.7. So let's take a moment and talk about a couple of these features, right? Not in too much detail here, right? But the feature that I want to talk about today is persistent memory, right? If you look at the pyramid here, that essentially shows the convergence of memory and storage. So if you look at the top of the pyramid, right, the technology at the top of the pyramid, that has the shortest latency, which means the best performance, but that comes at a very high cost relative to the items at the bottom of the pyramid, right? So these are technology layers, right? The top of the pyramid, these are technology layers which are comprised of DRAM, memory, and the CPU cache and the registers. Now, all of these components are accessed directly by the application using the load storage access, right? Now, when we start looking at the bottom of the pyramid, the technology at the bottom of the pyramid, now that's represented by the magnetic media. Those are your HDDs, right? Those are your tape, and the NAND flash, right? Which is represented by your SSDs and your PCIe workload accelerators. Well, they have a longer latency, and they have lower cost related to the DRAM or the technology on top of the pyramid, right? So these technology components, they have block access, meaning data is typically communicated in blocks of data, and the application are not accessed directly, right? So what we are missing here, right? What's actually missing here is a new layer we call the non-volatile memory, or the NVM. So this layer essentially sits between the NAND flash and the DRAM, and that provides the faster performance related to NAND flash, but it also provides the non-volatility, which is not typically found in the traditional memory offering. So this technology layer provides the performance of memory with the persistence of traditional storage, right? So AKA persistent memory. So essentially your PMM falls between the two ends of the spectrum, right? The DRAM and the flash storage. Now, the question is, how can application use persistent memory, right? So applications can use persistent memory just like DRAM over the DDR bus, right? So here the data is byte addressable with latency measured in nanoseconds versus microseconds, right? Persistent memory offers greater capacity points and, of course, lower cost compared to DRAMs, right? And the way we consume persistent memory, right, in VMware vSphere is using two modes, right? Either essentially using it as a block storage, which we call a vPMM disk, or using it in a DAX mode, right? And we call that V as a Victor, PMM, right? Now, use cases. The first use case that comes into mind is accelerated performance of Oracle redo log activity. Simply, we're putting the Oracle redo log on a data store, which is vPMM, right? By doing that, essentially what then happens is you are able to accelerate the performance of the redo log files, which is directly proportional to the performance of the Oracle database. Right? Another use case that comes into mind is you're able to improve the overall database performance if you're using the Oracle database Smart Flash, right? So essentially what happens is the primary cache is what's called the buffer cache, right? And the Smart Flash cache is called the secondary cache. And at some point of time, if the primary cache is full, these blocks which are not used, they get evicted from the buffer cache and they get destaged to the Smart Flash cache, right? And if you need, you have to read it back from the Smart Flash cache into the buffer cache, right? In this case, since everything is in memory, there is no destaging that's happening from memory to disk, and so performance is accelerated. right? And then you get better performance than what you had if you did not use persistent memory, right? So, and again, the link at the bottom of the slide here, essentially that's a white paper which goes into all of these use cases in great detail. I mean, it has the AWR reports and metrics and so on and so forth, so please do have a look at it. But I would like to talk about another notable feature of 6.5 and 6.7, and that's para-virtualized RDMA drivers, right? So, I mean, so what happens is with 6.7 and 6.5, right, there's a support for the PV RDMA drivers, and as we know, if you look at RDMA, right, that's a hardware transport protocol, right? That is essentially optimized for moving data to and from the memory. And what are the providers? Essentially, that provides low latency, right? It is able to bypass the operating system, right? So that way, it is able to reduce the latency in the software stack as well. And there's a CPU offload. There's a zero copy. And what's the use case here? The Oracle Rack Cluster Interconnect, right? So if you look at the Oracle Rack, the Cluster Interconnect Protocol for Rack, it's called the RDS, or the Reliable Datagram Socket. And that is agnostic to underlying RDMA-capable devices, and it simplifies implementation. So this protocol, well, this protocol can either work over an RDMA-capable Ethernet network interface card, or it can even work over an InfiniBand HCM, right? So, like I said before, essentially RDS, that's a reliable socket offload driver. It's an I2C protocol with a low overhead, low latency, high bandwidth. You're able to free up CPU cycles. It's agnostic to the RDMA-capable devices, and that can either work over an RDMA-capable Ethernet NIC or an InfiniBand SCA. So this could be used for the Oracle Rack Cluster Interconnect to speed up the cache fusion traffic, and inherently, you're able to accelerate the performance of the Oracle Rack cluster. All right. So moving on to vSphere 7.0, right? With the latest release of vSphere, which is vSphere 7.0, there's been a lot of features added, right? I mean, we won't have time to go through each and every one of them, right? But there are some notable features that I really want to call out, right, in the session today. Essentially, the improved distributed resource scheduler, DRS, right? The assignable hardware, the refactor demotion, etc. Right? So let's talk about the improvement in the DRS today, right? So if you look at the vSphere DRS, well, that used to focus on the cluster state, right? It used to check and see if it needed rebalancing, because it could happen the one ESXi server host is overcommitted, right? Or it's overconsumed, while another ESXi server has less of resources consumed, right? And what happens is the DRS logic will determine that, well, it could improve the cluster balance. It would then recommend, it will do a vMotion of those virtual machines. And that way, the DRS used to achieve a cluster balance by using the cluster-wide standard deviation model, right? With 7.0, the improved DRS, right, that takes a very different approach. What it does is it computes a VM DRS core on host, and it moves the VM to a host that provides the highest VM DRS core. See, the difference to the old DRS version is it is no longer balancing the host load, which means DRS cares less about the ESXi host utilization. Now what we care about is what's called the VM happiness, the virtual machine happiness. So we improve the workload balancing on the cluster by focusing on a metric that we all care about the most, which is the workload, the virtual machine happiness, right? So so that's to do with the DRS. Let me quickly talk about the refactor demotion, which is, I think, is very critical to mention here as well. So with vMotion, the key takeaway is that in the previous vSphere releases, right, what we did was we installed what's called the page traces, right, on all of the vCPUs. Now that used to cause the workload performance impact. Now during the stun time, we used to transfer the full memory bitmap, right, and think of large virtual machines, right? Think of monster VMs, right? This could be a fair amount of data depending upon the VM sizing. So what we decided was we needed to reduce the performance impact and reduce the stun time. And that's what we did with the vMotion, with the enhanced vMotion or the refactor vMotion in the vSphere 7, right? So in vSphere 7.0, what we do is we essentially claim one vCPU to do all of the page installing and the page firing, right? And then instead of doing it across all of the vCPUs configured for the virtual machine. So by using this method, this is far more efficient because the guest and the workload can continue to utilize all the other vCPUs without interruption. So one vCPU will now take care of setting all the page table entries in the global memory. To read only, it will handle the page tracer installer, the page firing, and so on and so forth. But all the other vCPUs will be helping the workload do what it is born and bred to do, right? So that was a bit on the refactored vMotion as well. So again, you could find, most of the details on these new features can be found in the link at the bottom of the slide. That is the vSphere 7.0 Resource Management Guide. But moving on. All right. So this slide is an overview of migrating the Oracle workloads to a VMware vSphere on premises, right? So as part of migrating Oracle workloads from one platform to another platform, right, the first order of business is to identify the nature of the source platform, right? So the source platform could either be a physical architecture. It could be a Sun Solaris Spark. It could be, the Oracle Solaris Spark. It could be the HPUX or the IBM AX environment, which we commonly call the big endian system, right? So, if you take a moment to look at the big endian systems, the big endian ordering, what it does, it essentially places the most significant byte first and the least significant byte last. And if you look at systems like the Windows or Linux running on x86, right, Intel or AMD, those are what we call the little endian systems, where the byte ordering is exactly the opposite, right? So as we can see, it's not a straightforward migration of Oracle database from the big endian system to the little endian system. This actually requires a block format change for every block in the database, right? Now, your second source could be engineered system. For example, the Oracle Exadata and ODA, which are essentially your little endian systems running Oracle Enterprise Linux. So the topic of migrating Oracle data from a big endian system to little endian, that's not an issue here, right? The third kind of source could be a virtualized platform, which is essentially a non-VMware platform, right? So this would also require a virtualization format, right, as well. So if you look at any of these three migration strategies, right, the above migration strategies, all three of them, right, they must take into account the best practices guide for the VMware vSphere specific version and the VMware best practices guide for running Oracle workloads. And again, the link at the bottom of the slide, that is the Oracle databases on VMware best practices guide. All right. So essentially we come here, right, and we talk about what does customers really want. Essentially what they want is a VMware hybrid cloud. So as customers, they move to the cloud, right, they are looking for ways to get best of both the worlds, right, without having to buy, let's say, new hardware. They don't want to do any kind of refactoring. They don't want to do any kind of replatforming. They want to make sure that they want to leverage their existing investment, their skill set, the tools, and so on and so forth, right? So if you look at the slide here on premises, right, essentially what they have familiar tools, they have familiar processes, they're able to leverage their existing investment, they're able to maintain the unique hardware and configurations, right? They're able to have granular control over placement of apps and data. Now with public cloud, what they want to do, or what they would like to do, is they want to scale faster. They want to reduce the cost. They want to establish global footprint. They want to have that pay-as-you-go model. They want to access a broader range of services. Now, see, if you look at the slide here, essentially what the slide is trying to say is today's complexity, that's hindering a full hybrid cloud value. There are some common challenges with the hybrid cloud adoption. Namely, there are operational inconsistencies. There are different skill sets and tools. There is disparate management and security controls. You have inconsistent application SLAs. And of course, you have multiple virtual machine formats. Right? So if you look at any of these, right, any of the hybrid cloud or any of the cloud vendors, right, or any replatforming exercise, typically, right, the application of the infrastructure rework, that is 60% of the cost, and that is 90% of the time. Now, in fact, I should probably go back to the slide here, right? Yeah, and if you look at the VMware hybrid cloud offerings, right, for people, right, for customers who want to adopt the cloud migration, data center evacuation, that's like the top use case, right? Followed by the DR/DC extension. Some of the use cases could also be data center extension. You have disaster recovery. You have cloud migrations. You have new generation applications as well. All right, so these are some of the current offerings that we have, right, in our hybrid cloud offerings as well. So currently we have the VMware Cloud on AWS that was G8 on 2017. The link is there for you guys to have a look at. And OCVS, the Oracle Cloud VMware Solution that Faisal will be talking about, that was announced September 16, 2019. We have the Google Cloud VMware Engine, GCVE, that got G8 June 20th, 2020. And then the Azure VMware Solution. So then you already spoke about the slide, and essentially the slide talks about the four use cases here, which is your data center extension, you have your disaster recovery, you have your cloud migrations, and your next generation applications. So I'm going to move on for essence of time. And this is very critical here, right? Essentially what this slide is trying to say is one needs to make sure that they read the documentation first. And once we do that, we deploy the virtualized workloads in production with best practices, right? And then using all of the new features that vSphere 6.5, 6.7, and 7.0 offers, we accelerate. And at some point in time, when we are ready to spread our wings, we then move our workloads for any of the use cases defined here to a VMware hybrid cloud environment. And this slide basically talks about how one would, after one virtualizes their on-premises, one virtualizes their workloads from physical to on-premises, right? One has a choice to move to any one of the 3 cloud vendors. The topic of discussion today is the Oracle Cloud VMware Solution. So without much further ado, I'm going to hand this over to Faisal here. Or if I can just take a minute, let me just talk about quickly about the new strategic alliance, right, before Faisal steps in. So essentially September 16, 2019, right, what happened was, the two great things happened. First was a strategic alliance, a strategic partnership was struck between Oracle and VMware, right? Essentially, there were 2 offshoots. The first offshoot was the Oracle Cloud VMware Solution that Faisal is going to talk about today, right? And that enables customers to run their VMware Cloud Foundation on an Oracle Generation 2, Gen 2 cloud infrastructure, right? The other thing is Oracle also became a part in the VMware Cloud Provider Program, which is essentially VCPP, and the OCVS solution will be sold by Oracle and partners, right? That's the first offshoot of the strategic alliance. Moving on to the next slide. The second offshoot of the strategic alliance essentially is a change, a landmark change to the Metlink document 249212.1 that essentially very emphatically states that customers with an active support contract and running supported versions of Oracle products will receive assistance from Oracle when running those products on a VMware virtualized environment. And it also says that this support policy does not affect the Oracle or VMware licensing policy. So 2 things to keep in mind. Oracle is now a VMware VCPP partner. We have the joint product, the Oracle Cloud VMware Solution, and there has been a landmark change to the Metlink document 249212.1, which was essentially created in November 8, 2010, right? That also talks about how Oracle RAC 11.202 onwards is supported on a VMware virtualized platform. And then at this point of time, I'm going to hand this over to Faisal.
Thank you, Sudhir. Thank you for taking us through all the requirements and the design and architecture methodology for business critical applications. And of course, talking about business critical applications and the industry footprint, Oracle is the first name that comes to the mind. Sudhir, if you could move on to the next slide, please. Yeah, so we're going to talk about how you can run your VMware workloads natively on Oracle Cloud. And the way you can do that, as Sudhir just said, one of the 2 announcements that were made September last year, one of them was Oracle Cloud VMware Solution, which basically gives you a native VMware environment on Oracle Cloud. Next slide, please, Sudhir. The mandatory safe harbor statement, I'm not going to read through that, but this is for product direction only. Next slide. Thank you. Now, getting straight into the things, Sudhir spoke a lot about what customers actually want, what they're looking for, and one of the key things that he brought up was a hybrid VMware environment is what customers are looking for. So if we actually take a step back and just take a quick look at some of the key factors that are driving cloud adoption for the enterprise customers. So the feedback that we continue to get from our customers is that on their enterprise IT strategies, they've now started to put some very important terms. Now, they are talking about data center consolidation. They are talking about minimizing their on-prem footprint to reduce TCO, to start enjoying the benefits of cloud. They are also looking to enhance their innovation efforts by utilizing all the breadth of cloud services that are available by a number of cloud service providers, and Oracle being there right up there on the list as well. Now, what this has actually done over the years is that organizations who were thinking about cloud as an afterthought, they've gone from cloud last to having a strategy of, okay, we will also have cloud, but now it's all about cloud first strategy. And as Sudhir said, it's all about hybrid cloud, it's all about how can I have parity between two different environments. Next slide, please, Sudhir. Thank you. Now, the customers who are actually embracing cloud and the customers who are actually planning to move across to the cloud, they've got some very key considerations. And us being Oracle Cloud Infrastructure, basically we work with some of the larger enterprise. We have been working for decades and decades with your systems of records, your most critical asset, which is your data. Now, when you talk about critical business applications, what could be more critical than your data? And Oracle, we have been custodians of data for a long time. And now in addressing those key concerns of our customers, the customers are thinking, if I move across to the cloud, will I still get the same performance, same experience that I'm getting in my on-prem environments? Now, what about the security? I have my environment sitting in my data center. It's secure. I've got my own security policies. Can I get that in the cloud as well? Now, once I move across, I just don't want to be pinned across. I want to explore the multi-cloud world. I want to look at multi-cloud solutions as well. And when I get all of that, what about the SLAs? What about consistency of performance? What about giving me the full benefit of cloud? Next slide, please. Now, having worked with the larger enterprises globally for a very long time, Oracle made the investment and went into public cloud. And what we have done is we have built a Gen 2 hyperscale cloud that is ready, that's geared to take on the most demanding workloads that the customers can bring across to the cloud. We address customers' concerns when it comes to performance, when it comes to security. We are ready to give the customers that jumpstart to their innovation journey on the cloud. What we have architected is a completely new cloud built for enterprise workloads, offering consistently high performance, where security is not just an afterthought. It is built on the principles of security. Now, it is not just cheap to get started with, but once you start getting onto Oracle Cloud, you continue to experience that lower TCO over longer periods of time. And as you scale out and you grow your footprint on the cloud, that TCO figure that works in your favor, in the customer's favor going forward. Next slide, please. So it's built for enterprise workloads. We've just spoken about who we work with. We work with workloads coming from different requirements, coming from different industry verticals. We've got customers in manufacturing, retail, public sector, financial services, airlines, you name it. Every industry is running Oracle workloads in their on-prem environments. Now, these are mission critical applications. These are high performance, high volume databases and applications. What our cloud gives them is it gives them consistent performance at par with their on-prem environments for the toughest on-prem workloads. And when you move across, what happens is that you need to do minimum re-architecture, and we're going to take a look at that, how that extends into our Oracle Cloud VMware solution as well. Now you migrate and implement your workloads on Oracle Cloud with minimum re-architecture, and of course getting the goal that you had in mind when you started your migration, achieve superior results. Moving to the next slide. Security. Whenever I talk about security at any forum, the first thing that I said, and this is, I quote one of our Oracle executives where he spoke about Oracle Cloud at Oracle Open World, and his thing was that Oracle Cloud is built on three principles, and they're security, security, security. So it's not an afterthought. It is a security first approach. Our methodology going forward and the way we've designed it, it should be always on security. It should be 100% automated. We should be able to give, and we do give customers security off the cloud, securing the actual infrastructure, providing inter-tenant isolation. So we've got isolated network virtualization when we talk about our infrastructure. So when a customer is on Oracle Cloud, they are completely isolated from other customers. we don't have access. I mean, we don't even trust ourselves. We don't have access to customers. Customers don't have access to us or to other tenants either. It's a least trust design. You allow what you want to communicate. By default, nothing will be able to communicate. And of course, what better when you talk about VMware and VMware security, network and security products as well, that ties right into that as well, that it's zero trust, least trust security. You allow what you want to communicate. Otherwise, even on the same network, same VLAN, nothing communicates. And as I said, core to edge security, security off the cloud, securing the infrastructure, security on the cloud, giving customers the virtual firewall, security policies, network security groups, web application firewalls, all of them are available right at your fingertips from your consoles, and also security for the cloud. So you can bring your own security postures, you can bring your own security vendors across as well, and pretty much have the same experience that you have on-prem. So security, we lay the foundations, we give you all the abilities to build a strong and secure foundation for your workloads on Oracle Cloud. Next slide, please. Thank you. Now, we've been talking about customers, what customers have been wanting. Sudhir mentioned that customers are looking to go into a hybrid environment. Customers who are running VMware on-prem, they are moving into the cloud. They are looking to venture into the cloud out of the various options that are available. Now, VMware and cloud, they provide, that combination provides great convenience and flexibility. When you talk about virtualization, basically reducing hardware costs, reducing application certification complexities, DR and faster service server provisioning. Sudhir spoke about the benefits of vSphere 6.5, 6.7 and 7.0 and all the enhancements that are coming forward. Combine that with the on-demand availability of resources on the cloud. Combine that with enhanced data security, easy paths to modernizing your workloads by leveraging the wide portfolio of additional services available on the cloud. What you basically get is you are getting you're shifting your innovation, you're shifting your IT innovation into high gear. You're now utilizing the availability of new and innovative services and enjoying the best of both worlds. You're enjoying virtualization with VMware, and you're enjoying the best of cloud as well. Next slide, please. Talking of the best of both worlds, VMware virtualization and public cloud with Oracle. When you bring these two, as Sudhir said, these two powerhouses, when they came together at Oracle Open World last year, basically the first announcement was the Oracle Cloud VMware Solution. Now, what exactly is the Oracle Cloud VMware Solution? It is an Oracle product which combines OCI and VMware software, where customers will be able to deploy a VCF verified environment on Oracle Cloud right from their fingertips. You log on to the console, you provide your specifications that you require. You start with a minimum of 3 bare metal nodes. So this comes with 156 OCPUs when you deploy 3 bare metal nodes. You get 2.3 terabytes of memory, and you're getting 153 terabytes of NVMe local storage when you deploy the minimum footprint of Oracle Cloud VMware Solution. Now, in addition to that, what you see on my slide is where I say it's a VMware Cloud Foundation verified solution, I'm giving you option with software versions as well. I'm saying you can run vSphere 6.5 or 6.7, and of course, as we go along, the other versions 7.0 and all will start to tie in, and that will also start to become available. We are giving you NSXT 2.5. We are giving you vSAN. Of course, when you're running your choice of vSphere version, you get vSAN accordingly as well. Now, that's just the beginning. That's not where it ends. That's not where it stops. This gives you the ability. This starts your journey to migrate your VMware workloads seamlessly across to Oracle Cloud, and then start connecting across to all the different native Oracle Cloud services. Talk about Oracle Autonomous Database, talking about Exadata, talking about our AI, machine learning, blockchain capabilities, data science services. All of those are now available to your workloads directly from your fingertips. You go to your console, it's as easy as a few clicks, and your workloads are connected and enjoying the best, as I said, the best of both worlds, best of VMware and best of Oracle Cloud. Now, again, this slide will resonate and will enhance exactly what Sudhir spoke about when he spoke from on behalf of the VMware customers who are looking to move across onto the cloud. Customers are looking to get a familiar VMware experience. When you move across to the cloud, you don't want to do a complete revamp of how you manage your infrastructure. You don't want to do a complete skill revamp of your resources. You want full control on your environment. You want to have seamless migration capabilities as well. And a key factor, you want global availability. Wherever you are, you want this to be available in your geographies. Now, the benefit of having a native VMware solution native to your cloud is that you can deploy it as you extend your region footprint. So what you see over here on my slide, we have got 19 regions live, and all 19 of them have got Oracle Cloud VMware Solution available today. So talk about the US, you've got Ashburn, Phoenix, San Jose, you've got 2 in Canada, you've got Sao Paulo. Go to Australia, you've got Sydney, Melbourne. Coming to the Middle East, you've got Saudi Arabia. That footprint is increasing. India has got 2 regions, and APAC again. You're talking about Japan and South Korea having 2 regions each. And what that basically means is whether you're in London, Amsterdam, Frankfurt, the US, Oracle Cloud VMware Solution is available to you right now. And the footprint will increase at a massive pace, 17 regions planned, and it's the pace at which we look at it is roughly about 23 to 25 days per region, give or take. I mean, I'm just giving rough figures. So that's how fast the footprint is increasing for Oracle Cloud, and that's how fast Oracle Cloud VMware Solution becomes available right in your backyard. So native VMware Solution with a global scale. And the key factor, another point on my slide, is it is also available in dedicated region cloud at customer. So if you take a dedicated cloud at customer, dedicated Oracle Cloud region in your data centers, you have OCVS available over there as well. So it's all about having it right where you want it and when you want it. So the benefits are of combining these two are far beyond putting them on slides. Familiar VMware experience, as a number of my colleagues say, and the way we like to put it, it's just VMware. So you've been running VMware on-prem for years. When you bring it across to Oracle Cloud, it's nothing different. It's a very familiar VMware experience. It is a dedicated native VMware cloud offering, which gives you complete administrative control. Now, those 3 words, what that basically means is you, exactly the way you're managing your environment on-prem, your vCenter, your NSX manager, and logging into your ESXi host, you still do all of that exactly the same way. Once the servers are provisioned, they are handed over to you. You leverage the same experience, the same tools, same process, your lifecycle policies to manage this environment in any way you want it. You can change the architecture in terms of what logical switches you want. You want to do something with vSAN. You want to change your HA policies, your DRS. It's totally up to you. It is your environment. You get full administrative control. So there is nothing mandated on you on how you should run it. You continue to run it. You can manage it yourself. You can have your partners do it, or you can have Oracle manage the environment, excuse me, for you as well. But the key point to note over here is it's exactly the same. When I say it's consistent, consistency in performance, consistency in cost, consistency in the management experience as well. And all of that, of course, so when you talk about Oracle Cloud, all of these are covered by SLAs as well, performance, manageability, and availability SLAs as well. So the experience keeps getting better as you move across. Thank you. Okay, so I've decided to provision OCVS. What can I actually do with this? So we have discussed this over the last the course of this presentation already, but the three key factors, the three key use cases that customers do and will continue to work with: migration to the cloud. So basically they are, as I said, they're consolidating their data center footprint on-prem, or they're minimizing it. So whatever they have on-prem, they are moving it across to the cloud. The next thing is hybrid deployment or capacity expansion. So why should I invest in another data center on-prem? I'll just subscribe to Oracle Cloud VMware Solution, and that will become my data center 2 or DC3. And I can connect them using VMware's HCX, SRM capabilities, and other tools available. Your capacity expansion is there. You've got a hybrid deployment directly from your respective VMware and OCI consoles. Disaster recovery, speaking about SRM and HCX, of course, you've got a disaster recovery capability where, again, bringing the best of both these infrastructure from OCI, OCVS on the cloud and VMware software, you start to gain redundancy for your critical services. So now you've got a disaster recovery in the cloud. But when you look at across the slide, all of that, the key factors would be rapid lift and shift, whichever use case you're picking up. You are doing it with minimal disruption. You're getting maximum efficiency. All of it is getting managed from single integrated views, whether it's the VMware view or the Oracle. It's exactly what you've been used to. And basically you're enhancing your redundancy and your availability capabilities for your workloads. Now let's start looking at the provisioning process. Once you start to decide to provision OCVS, you log on to the Oracle Cloud console. The first thing that you do is you go in, you provide how many hosts you require, what version of vSphere are you going to run, whether 6.5 or 6.7. We give you the capability to choose what version you want to run. We give you subnet. Now VLANs, again, we're providing layer 2 networking with this service, so you get VLANs the same way, again, consistency of experience. We provision the VLANs the same way you do it on-prem as well. Each VLAN and subnet has got route tables and network security groups to make sure that communication happens with the external environments, and it is all secure. So network configuration comes up first, the footprint, the versions, and what's the network range that you decide to use for your OCVS solution. From network, we move on to compute. As I said, the first thing that you do is you choose which region you're deploying it in and which availability domain you decide to deploy it in. So you choose the AD, the region. The hosts will get deployed across fault domains in the region itself. You decide which virtual cloud network you're going to use for this. The instance type that is getting provisioned is what we call the bare metal instance dense IO 2.52. So 5.2 is the number of CPU cores that this shape has. It's got 768 gigs of memory, 52 terabytes of storage, and two 25 gig NICs available on it. Minimum capacity, as I spoke before, 3 nodes, 156 CPU cores, 2.3 terabytes of memory, and 153 terabytes of raw storage, which gets configured into vSAN by the provisioning service itself. The next thing that happens is we chose what networks you want to use. We chose what versions you want to use. The networks get deployed. The routing, the security policies get deployed. The next thing is that the VCF bundle gets deployed on the ESXi servers. So depending on what version you choose, we've got 6.5 update 3 or 6.7 update 3 available. you get vSAN 6667 and NSX T2.5.1. Provisioning service will install each of these components on your hosts. It will install vCenter, it will install the NSXT management cluster and give you direct access onto that. So we install it, we configure the cluster. What you basically get is login details into your environment. There we go. Once the provisioning service is complete, this is the view that you get. You get your environment, Oracle Cloud VMware Solution, with your vCenter information, your NSX manager information. Next slide, please, Sudhir. Thank you. Okay. This is the logical view that gets deployed. One, ESXi hosts are provisioned. ESXi hosts have got NSX, vSphere, vSAN components installed and configured. Networking for SDDC functions is configured. So you've got management, vMotion, vSAN, VTEP for NSX Edge for your host as well, and uplinks for north-south traffic. All of that gets configured. vCenter and NSX Manager are installed and configured. And NSXT, the minimum configuration is done. So when you provision your first logical switch and put your first virtual machine, we have configured your tier 1, your tier 0, and the routing down to the virtual cloud network as well, so that it's plug and play for your first logical switch. If you provide us with the CIDR of the first logical switch during provisioning, we do that bit for you directly from by the provisioning service itself. So you just provision the first VM and you're good to go. But of course, there are other things which I'm going to speak briefly about going forward. But again, vCenter, NSX Manager, NSX Edges, tier 0, tier 1 on the NSX, that's configured. Your VLANs are configured and your ESXi hosts are available to manage directly. Now we'll go one by one on the different sections of the console itself. The first and the foremost, the most important one is where is my vCenter, what's the login URL, what's the IP address. That's available from the console. We give you an initial password. You go ahead, you change that. It's the same administrative at vsphere.local. You want to change this, you can change this going forward. The admin credentials for NSX Manager are there as well. Once you change it, the environment is yours. We don't have control over it. We don't know what you're doing with your environment. It's yours with full administrative flexibility. Moving on to the next section of the console. Next slide, please, Sudhir. ESXi hosts. Assuming you went ahead with 3 nodes, so you've got 3 hosts provisioned. It gives you the details of the 3 vSphere hosts that have been provisioned, the status of those, what are their names, where are they deployed, and when did the provisioning happen. Moving on to the next one, another important aspect, which is networks. All the VLANs, the respective IP address ranges, what is the plumbing for your SDDC, all of that is available from the console as well. The next one is work requests. I'm not going to go into that. That gives you exactly what you've done with OCVS and the different functions that you've performed within OCI for your environment. Right size or terminate your SDDC. Of course, add hosts, remove hosts, or if you want to completely terminate, which once you're on OCVS, I don't think you would want to go back, so you would probably expand your footprint. So, but you can do your edit of your SDDC or termination right from the console as well. From the same view, it is all available. Moving on to the next one, please. Networking quick actions. We've deployed the bare minimum. Now you want to expand your footprint and you want to connect to on-prem, you want to connect to the Oracle Services Network, which are all the Oracle Cloud services. Connect to the internet to provide internet connectivity to your workloads, and of course connect to other compute resources within the VCN. All of that is also available. You go on to these respective quick actions. We do the OCI part for you. We configure it directly. You can do whatever you want to do in NSX Manager, and we basically take away the overhead of configuring anything in OCI, and we provide automated workflows for you to be able to connect across to whatever destinations you want to connect. Full controllability. If you talk about the life cycle, you provision your SDDC, you have the ability to right size it, you add hosts. Once you add a host, it gets provisioned as a standalone host. You can go ahead and add it to the cluster whenever you want it, as you want it. If you want to minimize your footprint, you want to remove a host, you can do that from the console as well. And of course, manage your environment, customize, update, operate using vCenter, using NSX Manager, OCI console. You get API access, and yes, you get SSH access to your ESXi hosts as well. You can do SSH directly onto them using an SSH key that you provide us with when you start your provisioning process, and you can use SSH to do whatever functions, any third-party components, any ESX stop kind of things. You can do that on your ESXi hosts as well in your management lifecycle. Next slide, please. Thank you. Connecting across to your SDDC to on-prem environment, we've got Fast Connect, which is always going to be the preferred method, because using that, if you have link mode configured, you can do vMotions between your environments in your on-prem and cloud environments as well. But basically, this just lays the foundation for any future use cases. So you can have Fast Connect as the primary, and you can use VPN Connect as a secondary mode of connection, or two Fast Connects and a VPN Connect as a third failover option. But this basically lays the foundation for all the use cases that we've spoken about. Again, just enhancing that experience, providing you the ability to leverage this in the best possible manner. Next slide, please. Access to Oracle Cloud Services. You go onto your console, use the quick actions, you provision, you click on the workflow to connect you to the Oracle Services Network. What it will do in the backend, it will provision the service gateway, it will configure the network security groups, it will configure the route table as well. And basically, once that networking workflow is complete, you can go ahead and connect the two endpoints. Considering you're connecting to an autonomous database, you just connect that. This is private connectivity from within the OCI network itself. You get direct access to the entire Oracle Cloud service portfolio. Next slide, please. Thank you. Last but not the least, a DMZ in your environment. So connecting to the internet, providing outbound access using NAT gateway, or publishing your applications to the internet as well. So we've got the internet gateway. You can use that for inbound or outbound access to the internet. Again, you decide which way you want to go, how you want to do it. All guidelines, all white papers are published on the OCVS website, and we will allow you to do all of that. But again, the quick action workflows are available for you to leverage them. We do the OCI bit for you in terms of the configuration. You configure your VMware environment and you're good to go in terms of your DMZ. So enhance it with OCI security and NSX security, and you've got that enhanced security experience that you wanted in the cloud. Next slide, please. Key operational takeaways. This is a very, very important slide. These 4 items that I've listed on the slide here. 1, you have complete control over the cloud stack. What that means is access to vCenter, access to NSX Manager, SSH access to your systems, change what you want when you want it. You're running troubleshooting, installing VIBs, installing any third-party applications. You have OCI API available for this as well. Next one, it's a secure, isolated, and dedicated environment for you. Security is within OCI is available. We configure it by default. You can further tighten it or loosen it as per your requirements and enhance it with NSX security in your SDDC. Software versions, updates, and upgrades, all according to your choice. You choose to which software version you want to provision. You choose which version to upgrade to, when you want to upgrade to, according to your own lifecycle policies and procedures. Last one, server failures and support. In case of any server failures, customers just go in and provision another host and replace the faulty host in their SDDC. That's as easy as that. In terms of support, Oracle is providing Tier 1 and Tier 2 support and a warm handoff to VMware for any T3 support cases. So these will be your key operational takeaways when you start managing your OCVS environment. Next slide, please. So on this slide, this just gives you the summary of everything that we've spoken about. And the way I will end it is your applications in your VMware environment under your management, all according to your lifecycle policies with the leading Gen 2 cloud SLAs available. With that, I'll hand it back to Sudhir. Thank you very much.
Thank you, Faisal. So to quickly wrap up, moving on, there are a lot of links up here that speaks about running your Oracle workloads on a VMware environment. We also have the Oracle support and the licensing guide as well. There's an external solution page, which is essentially the business critical application page where everything and anything to do with Oracle is hosted there. The one thing that we like you to take away from, from running Oracle workloads on a VMware is the one-stop shop. Essentially, any other collateral that is produced, right? Whether it's Oracle best practices or the rack deployment guide or Oracle on vSAN or even on OCBS at some point of time, the deployment guides, everything and anything can be found in the one-stop shop link here. But I think we are at the end of the session. So that's a bit description about me, and this is about Faisal. So thank you for listening to us, and we are now open for question and answers.